Hi everyone, today we're just going to real quick review how to add and subtract mixed numbers. And just real quick, I do have some extra notes here. It's just to let you guys know that the associative and the communicative properties, they both work with mixed numbers the same way that they work for whole numbers. So what exactly does that mean? Well, remember we said, with whole numbers, the order doesn't matter when we're adding. It does for subtraction. The order does matter for subtraction, but now we're adding. So if I had 2 3/4 plus 1 1/4, it's the exact same as 1 1/4 plus 2 3/4. Okay? And now down here, I have 3 fractions. Okay? And so remember, it doesn't matter the order. So we can add these numbers all up. And I can group with parentheses. I can group 2 of these fractions together, so 2 3/4 plus 1 1/4, and then add the 3 2/4 last. Or I could group it a different way, and I could add the 3 2/4 and the 1 1/4, and then add the other mixed number last, and I will get the exact same answer. So quickly, just to prove it, 2 3/4 plus 1 1/4. Well, the 1/4 and the 3/4 would be one whole. So 2, 3 plus 4. And then if I add the 3 2/4, okay, that'll give me 7 2/4. And then over here, if I add these together, I would get 3/4 from my fractions and 4 whole. And then if I add the 3/4 to the 3/4, I get 6/4, or I would have an extra whole with 2/4 remaining. And then 1, 2, 3, 4, 5, 6, 7. So it does not matter which order you add your mixed numbers in, you'll still get the same answer. Okay. Real quick. Like I said, we're just going to review. So pick your strategy, okay? If you chose to rename these as improper fractions, add and then turn it back into a mixed number, use that strategy. Or if you just do the normal regrouping strategy, okay, you can do that as well. Go ahead and pause the video, and we'll solve it together in just a moment. Okay, so let's see what you have. So if you did the converting into an improper fraction, okay, 5 times 8 is 40, plus 4 is 44, over 5. And then 5 times 1, and I'll just redraw these in case you forgot. And by the way, you can always go back and look at the previous videos if you ever need a bit of a refresher on how to do any of this. All right, so 5 times 1, it's not a good addition symbol. 5 times 1 is 5, plus 3 is 8. All right, carry over the 5. So when we add these together, remember, our denominator stays the same. 44 plus 8 is going to give me, what did you get? Should have gotten 54. I'm having a, nope, 52. I need y'all with me to keep my brain working. All right, so when we divide 52 by 5, okay, should easily see that 5 can go into 52 10 times, and that will have a remainder of 2, okay, because 10 times 5 is 50, 52 minus 50, remainder of 2. So now we have our whole number, we have our numerator, and our denominator is staying the same. So 10 2/5, okay, using the converting into an improper fraction strategy. If you did just basic regrouping, okay, 4/5, starting with your fraction pieces, 4/5 plus 3/5, okay, And as always, if you need to draw a quick sketch, okay, just to make sure you got it right, there's nothing wrong with that. So, let's see. I had 4/5 here. 1, 2, 3, 4. And then I added 3. So 1, 2, and 3. All right. So I got 1 whole. So that's going to get regrouped. And how many were left over? 1 2/5. Okay. And just adding up the whole numbers now. So 8 plus 1 plus 1 is 10. So 10 and 2/5 is what you should have gotten here. Okay, now quickly review your strategy for subtracting mixed numbers. Again, if you chose to, regroup and add 1 whole fraction to this, because here we have 9 1/3 minus 2 2/3. I cannot take away 2 from the 1. So you are going to have to either regroup or rename these as improper fractions. So go ahead, pause the video, solve using the strategy of your choice. All right, let's see. If we did regular regrouping, the 9 is going to become an 8, and I'm going to add 1 whole to this fraction here. So my denominator is going to be the same. So what will my numerator be? Should have gotten 3. 3/3 is equal to 1 whole, which we borrowed from here. So this will now become 4/3. And now I can subtract the 2/3. So 4/3 minus 2/3, 4 minus 2, easy peasy. And now just subtracting the whole numbers. 8 minus 2 is 6. So 6 and 2/3. Let's see if those of you who solved this the other way got the same answer, okay? So 9 times 3 is 27, plus 1 is 28. Carry over your denominator. Okay, so 28/3. And then same for the one down here. Okay, 3 times 2 is 6. 6 plus 2 is 8. Carry over the denominator. So here when we subtract, okay, pretty easy. 28 minus 8 is 20. 3. All right, now let's divide. 20 divided by 3. How many times can 3 go into 20 without going over? Well, the answer is 6. Okay, so 6 times 3, that's 18. If we subtract that, we'll find our remainder, which will be 2. And there we have it. Whole number of 6, numerator of 2, and 3 is still our denominator. So no matter which way you do it, you will get 6 and 2/3. So like with everything else we've done this year, I give you guys choices and strategies because I know, some work better for you guys than others. So choose the strategy you prefer, and today you actually have a choice between activities. There is a tic-tac-toe game that you can play with, maybe an older sibling or parent. And then there's also a pizza parlor activity sheet, which does have models. So if you're maybe still unsure, that might be a better activity to do because it does have the visual aids with it as well. But whichever one you choose, just go on to Dojo and send me a picture of your work, and that'll be it. So I'll talk to you guys later. Bye.